All right, so this is a proton, so it's got a charge of positive 1.60 times 10 to the negative 19 coulombs. So what we'll do is we'll just compare the electric force versus the magnetic force, see which one's bigger, or if they're equal. If they're equal, then it will go unscathed. So we're talking about when the particle reaches the area between the plates. So the electric force is going to be done by the electric field. So it's going to be QE. So we'll use the charge of the proton. And we'll use the given electric field, which is going to be down, just based on the fact that the positive plate is at the top, the negative plate is at the bottom. Okay, so that's how much electric force the proton will feel. And now we'll just calculate the magnetic force, which you have to think back to last week or look up the formula from last week. The magnetic force is going to be QVB. That's the formula for it. There's also a sine theta term, but this charge is entering at a 90-degree angle to the magnetic field, so sine of 90 is just going to be equal to 1. So it does not really affect this equation. So you see that both the electric force and the magnetic force have Q involved. It's being multiplied by Q. So I don't think the charge of the particle actually matters because it's used the exact same way on both equations, but we'll just calculate the whole thing out here. V is the speed or the velocity, which is 3 times 10 to the 6. And then the magnetic field B is given as 4 times 10 to the negative 4. Okay, so we multiply that out. Um, 19.2 times 10 to the, do some exponent laws here, negative 17, or written properly 1.92 times 10 to the negative 16 newtons. And that would, well, it should be up. I'm just going to double check with my right hand rule. So I'll get my index finger pointing to the right, my middle finger pointing into the page, and yes, my thumb points up. So that is correct. So these two forces are going against each other, but it looks like the electric force will win. So this particle is not going to go unscathed. It will deflect down.